So transformations of functions is what we're talking about. We spent 2 days on this. Okay, we're going to learn 4 basic parent functions, right? That's a function before you mess with it. We talked about absolute value functions 2 days ago for you guys. And then we're going to talk about all different transformations of those functions. Your first blank space is family. So a family of graphs and equations of graphs that have at least one characteristic in common. The parent graph, talked about that on block day, is transformed to create other members in a family of graphs. So we're going to talk about 4 different parent functions. So this first one here says f of x equals a, where a is any real number. So we're just going to make up a number, right? So where we plug it in, it's always that number. And I'm going to make f of x equals 1 to make up that number. So every single time the y value or f of x is 1. Every single time. So when I graph that thing, super easy to graph. We just have a big fat line right there at 1. And I need arrows on the end. Give me some arrows on the end. Okay. Ryan, what's the domain of that function?
All real numbers.
All real numbers. And then the range. So if it's just so abstract to talk about this, that's why I wanted to just give you an actual number, because it's weird to talk about f of x equals a. So if it were a, this would be an a right here. Like the tick mark would be an a, and that's just weird, right? So I think it's just easier to talk about a number. So if we do the range, we're going to do set builder notation. And we're going to say f of x, right? Because that's what this y value is right there. They say f of x instead. So when you do the set builder notation, you also need to say f of x. What's it always equal? 1. So if I gave it to you with the a, you would just write an a here. But I just find that unnecessarily confusing. So that's set builder notation with the brackets. Okay? That's a constant function, by the way. I forgot to emphasize that. Constant function. That just means it always equals a number. Like y equals 2 is a constant function. Okay. So if we have f of x equals x, so when I plug in negative 3, what do I get? Negative 3. Oops. When I plug in negative 2, I get negative 2, negative 1, 0, 1, 2, 3. So show me with your arm what that graph looks like in the coordinate plane. Right, so think about it, right? So start graphing those order pairs. Negative 3, negative 3. Negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, 3, 3. Right, we just have a diagonal line. Okay, arrows on the end. Jackson, what's the domain? All reals. Good job. Tori, what's the range? All real numbers again. Okay. Easy. So that's an identity function. Why is it called identity? What are x and y? The same, identical, right? Yes. That's what I was going for, exactly. They're identical, right? So you can remember identity function because x and y are always the same, okay? So I would highlight that or underline it or do your thing, right? So f of x equals x. If it helps you always think about it like y equals x, you can think about it like that as well, okay? Absolute value function looks like what? Show me with your arms. You guys are right that time. Yes, like that, right? Like this. Okay? So when I plug in -3, I get 3. I get 2, 1, 0, 1, 2, 3. So we start at 0, 0. We just go diagonally up to the right and diagonally up to the left. And then we draw our little V. Arrows on the end. So when we talk about domain on that one, what do we get, Maddox? All real numbers, very good. How about range, JR? Good. Let's write in set builder notation again. So we write y such that y is greater than or equal to 0. If we wrote, this is set builder notation I just wrote right here. If we write domain and interval notation up here, how do I write it? It's been a while since we did that, right? And you have a test coming up next block day. So just remember, that's how you write it in interval notation. Just so you remember what the difference is. Interval's that one. Set builder is the one down here with the brackets. Okay? So we have identity function, which is just linear, right? We have absolute value function, which makes a V. So if you get mixed up on things, you could write identity as linear. So you remember it's a line. You could write absolute value is a V. So you remember it looks like a V, right? It's never a bad idea to do that kind of stuff. Quadratic looks like a what? Right, like a U or a mountain, upside down U or right side up U. What makes it upside down? Negative in front. Good. Okay. So now we're squaring things. So just to emphasize this, because kids mess this up all the time. If I put this into my calculator, what's the answer? Not 6. Right? It's a common mistake kids make, right? You just multiply instead of like square it. Is it 9 or negative 9? What's the answer for this problem right here? Who thinks it's positive 9? Raise your hand. Who thinks it's negative 9? Raise your hand. You're right. Watch. So what the hell, right? Literally, the first time I put that in the calculator, I was like, the calculator is broken. That is wrong. Like, it made me mad. So if I do it like this instead, negative 3 squared, that means negative 3 times negative 3, right? So the exponent only applies to the number next to it, not the sign in front, unless it's in parentheses. So I just want to emphasize that. That's why teachers go crazy about you guys using parentheses, because if you don't, you're way off, right? You're 18 off. That's big. And if you're squaring 10, you're 100, 200 off, right? Negative 100 versus positive 100. So that the error gets exponential. Literally, it's an exponential function. Okay. So we're squaring. Negative 3 times negative 3 is positive 9. Negative 2 times negative 2 is positive 4. Positive 1, 0, 1, 4, 9. Okay, so we're going to graph this thing. So this thing has symmetry, right? We can have our first little talk about symmetry, remind you all the way back from Algebra 1. So it's symmetric, it has what's called line symmetry, meaning I can take these ordered pairs, fold it over that line, and it'll exactly match up. So when I graph this thing, I can just go, I was 1 away from that y-axis there, I'm 2 away over here, and I'm 3 away over here. So you don't have to think that hard when you graph it. Then you double check, make sure you didn't screw anything up. I'm good. And then draw in your little curve, right? X squared graphs curve. So absolute value graphs in quadratic graphs, right? This is a quadratic function, good thing to highlight. Those, like the domain and range behaves the same. So what is the range, John?
All real numbers.
All reals. And then if I want to do the range, what's the range, John?
All real numbers.
No. Boo.
Oh no. Y is greater than 0.
Is it equal to? How do you know it's equal to? Because there's a closed dot right there, right? That's what makes it equal to, because it includes 0 as well. Right, and the arrows are going up, that's why it's greater than. So if we're upside down, the only change would be the inequality switches from greater to less than. Okay? So that's quadratic. So get your calculator out. We're not doing it on Desmos. We'll do it on your graphing calculator because I want you to know how to use that. Need to borrow one, grab your phone and grab one up here. Oh, that's too many already. You're too late. Oh, I forgot I have them locked over here. And I don't think you can borrow them. Because I think my keys are in the other backpack. Yeah, sorry. Keys are in the other backpack. My bad. Put your phone up again, though, please. Oh, that's annoying. I thought I had everything switched over. I don't. That doesn't. You need new batteries. Yeah. Okay. So if you have a graphing calculator, and if there's like only 1 or 2 in your table group, just look on with somebody. It's totally fine. I'll show you how to do it. Remember, when you put in absolute value, you want to hit y equals first. To get absolute value, you hit math, which is right below alpha. Go over to number, and absolute value is your first choice. So you hit math, right arrow to number, and hit enter. The first thing we had on that was x plus 2. You might remember from block day, where's this move, left or right 2? Left. Right? So when it's plus inside of the bars or inside of the parentheses with the squared, it moves the opposite direction of what you might think. Because it's squaring or taking the absolute value, that's why. So this one moves left 2. How about x minus 2? Where's that move? Right 2. How about plus 2 after? Up 2. Minus 2 after? Down 2. Now let's put in, what do you think happens to the y values? Because we're multiplying by 2. Is it a vertical stretch or a compression? So I want to put in, I'm going to take this out. So here's the parent function, right? 0, 0. Look, you can, so you know your TVs are like 4:3 aspect ratio or 16:9. So they're stretched out. Like movie theaters, the screen's wider than it is tall. That's what this calculator window is. So if you want it to look square, you can hit zoom top middle and hit 5. And then it looks like a proper V, right? So if we take that and then do absolute value of x and we do +2 after, then you hit graph. And the red graph is just adding the 2, right? So it just moves up 2. Now if we go, the green one's going to be 2 absolute value of x, just so you can see what they look like. Right, so the y values, they're doubling each time, right? So it's way skinnier. So that's called a vertical stretch by 2. You have to say what the stretch is by. That's important. So if the one right here is a vertical stretch, what's this one? A vertical what? Compression. So vertical compression by 1/2. So if we make it negative, what's it do to the absolute value? So let's put it in and see. I'm going to clear out some of these just for... So if I put a negative in front right here, flips it upside down, right? That's called the reflection over the x-axis. Remember I told you how flashcards are a good idea? Make some flashcards for these, right? Try to fill out the second column on your own. I'll give you a couple minutes to do that. You can use the column on the left as a reference because it works the same. I'm going to freeze the screen and then you can double check your answers. You can double check as you go. Okay, so it's essentially the exact same thing, just different numbers, right? Left 3, down 3, up 3, right 3, vertical stretch by 3, vertical compression by 1/3.
Why is the 3 instead of 9?
Because if you square x plus 3, that means you multiply x plus 3 times x plus 3. So it'd be like x squared plus 6x plus 9. So it's different, right? If we're just 3 in the parentheses, then yes, it is 9. Okay? Good question. Remember, you can always, how do you check your values on the graph? Like if I made you fill out a table, what do you hit? Second what? Second graph to check the table of values, right? So you can use your calculator on the test to do that. Anyone need more time writing that down? Or a couple of people are still writing. No rush. So below, when you add or subtract, I'm writing it small because I'm going to write a bunch right here. I didn't feel like there's enough in there. If you add or subtract within absolute value or parentheses, then it slides or shifts a function, as in it goes left or right. Okay? So I don't really like slides or shifts because I don't know which way you're shifting. You could slide up and down, left and right. So I would even cross that out. Just write that. So when you multiply or divide, it stretches or compresses. Multiply or divide. Stretches or compresses. Okay, when you have a negative in front, it reflects it over the x-axis. I wouldn't say flip. Reflects over x-axis. Okay. So to me, like this doesn't help me at all. Like seeing the examples above, it was what really helps me. So if I'm making flashcards for this stuff above, I would put this on one side of the flashcard and all this stuff on the other side of the flashcard. I've had freshmen before, I ask them to make flashcards and they put all the information on one side. I'm like, that's not a flashcard then. You got to be able to flip it over and like test your knowledge, right? Things I thought I'd never have to say. Okay, so more, this is like the technical verbiage. So if we shift it, we're shifting it H values. Which way does it go if it's plus? Left. I would just put a squared on there. I think it's better. Left. Right? We're shifting, H is just this in the parenthesis, right? So it represents any number. So H units right is the next one down. Then it's K units. This is based off a formula we're going to be using, which I'll write it for you just so you can see it. So that's like vertex form of a quadratic equation. Because H and K is a vertex. They basically run out of letters. That's vertex form of a quadratic. So that moves a K units up. This moves a K units down. So if it's bigger than 1, meaning you're multiplying by 2, 3, 4, whatever, then the graph is vertically stretched. Next one down, if it's less than 1, as in you're multiplying by a fraction. So you could write fraction in there so you remember. Then it's vertically compressed. And then if there's a negative in front of the function, it reflects over the x-axis. Okay. So, what's upper left? Braden, right here. What is it? You can use your notes for help, right? That's the whole point. We're just practicing. Where's it move it? You got it, Braden. No, you're better than that. He phoned a friend. Up 3. How about this one right here? Anyone? Look at it on your paper. You can do it. Left 7. Good. Okay, how about this one has 2 transformations. What's this one in front? reflect over the x, and right 4. So reflect x, right 4. So I like number them, go in left to right order. Reflect x. And right 4. Okay, how about the one below that? What's a 5 do? Vertical stretch by what? And then what's a +1 do? No, not left. It's after the function, so up 1. Good. This one has 3, right? So it's got the negative in front. So it's reflect x. What's a 2 do? Vertical stretch by 2. We'll even abbreviate VS by 2. And then the -1 goes right 1. Vertical stretch. 1/3 is a vertical what? Vertical compression. We'll write it out for John. He wanted more. By 1/3. What? All right, +2 does what? Left or right? Left. Left 2. -5. Down 5. Okay, the 4/3. Is 4/3 bigger than 1? Yes or no? Yes. So that's a vertical stretch by 4/3. Vertical stretch by, it's all John's fault, 4/3. Okay. +2 at the end goes up 2. Oh, I didn't write your homework down. Here it is. Homework is page 63. 1, 2, 5, 6. They're not very long problems. That's why there's more. 1, 2, 5, 6, 21, 24, 25. 37, 38, 40. And 50. Okay, write that down. Oops.